Hello students, welcome to Learn It. Respect to factors affecting the electrode potential, we discussed about the electrode material. Second one is temperature. So with respect to temperature and the concentration of the electrolytes, Nernst equation is the solution because Nernst equation is having both the factors, that is temperature and concentration of the reactants. With this knowledge, so let us proceed with our next concept. So consider it is NTP and we have a cell which is made up of electrodes. Both are copper, which are connected by salt bridge, but externally voltmeter is connected. So here the concentration of both the solutions is 1 molar. Then the question comes, what is the voltmeter reading? It is 0 volt because at NTP, at 1 molar concentration of the electrolytes, both of them are having the electrode potential, that is standard reduction potential of 0.34 volt. That's why this cell, that is E naught of this cell, is equal to 0.34 minus 0.34, which is equal to 0 volt. So this cell does not provide any electricity. But what if we change the concentration of one of the cell? But what if we change the concentration of one of the electrolyte? So here we increase the concentration. Then it is understood that C2 is greater than C1. It means the concentration on the right hand side is greater than the concentration on the left hand side. Then this cell is represented by the formula copper, which is in contact with Cu plus 2 solution, whose concentration is C1, which is connected to salt bridge, which is connected to again Cu plus 2 ions, but its concentration is C2, which is connected to copper. At this condition, the electrode with higher concentration starts to undergo reduction. So if it starts to undergo reduction, means it acts as a cathode. Electrode which is having lesser concentration will starts to undergo oxidation. So here the copper on the left hand side starts to undergo oxidation to give Cu plus 2 ions, whereas on the right hand side the Cu plus 2 ion starts to undergo reduction to become copper. Here both the materials of the electrode are same, but the concentration in which they are dipped in are of different. So such type of cells are called as concentration cells. Remember, this is a galvanic cell. So concentration cell is a galvanic cell in which both the electrodes are same material, but the solutions in which they dipped are having different concentrations. Now we get a question, what is the cell potential or what is the voltmeter reading? Again, we know that there is no standard concentration. Then we need to apply Nernst equation to this cell. So E of this cell can be calculated by the formula E of cathode minus E of anode. E of cathode is E naught of the cathode, that is E naught of the Cu minus 2.303 RT divided by NF log of 1 by what is the concentration of the cathode, that is C2. E of the anode is E naught of the copper minus 2.303 RT divided by NF log of 1 divided by concentration of C1. It means left hand side. So E of cell is equal to E naught of copper minus 2.303 RT by NF log 1 by C2 minus E naught of copper minus 2.303 RT divided by NF log of 1 by C1. Bracket complete. So here we are going to extract E naught of copper on left side. So E naught of copper minus E naught of copper, which will get cancelled. But here the minus of 2.303 RT divided by NF into bracket, this is log of 1 by C2 minus log of 1 by C1, because we have taken the minus outside. This gives here E naught of Cu plus 2, E naught of C plus 2 get cancelled. So minus 2.303 RT divided by NF into bracket log of 1 by C2 minus log of 1 by C1. So we know log of M minus log of N is equal to log of M divided by N. So minus 2.303 RT divided by NF log of C1 divided by C2. We know another logarithmic relation, that is minus log M is equal to log of 1 by M. So that's why, so here minus sign, it goes up, so it flips the C2 up and C1 down. So and at the end we get 2.303 RT divided by NF log of C2 divided by C1. So the condition must be known that here C2 indicates the higher concentration and C1 indicates the lower concentration. So C2 must be greater than C1. So overall we can say that E of cell of concentration cell is equal to 2.303 RT divided by NF log of concentration of the cathode divided by concentration of the anode. This is called as Nernst equation for the calculation of cell potential of concentration cell. We can conclude galvanic cell in a single video. So galvanic cell is a device which converts chemical energy of spontaneous redox reactions into electrical energy. Galvanic cell containing two electrodes connected by salt bridge, which can be represented by two vessels in which two different metals are in contact with their own electrolytes. Here left hand side is having different metal and right hand side is having different material. So left hand side it is anode and right hand side it is cathode. It is anode because it is having the negative charge. So the cell is represented as M1, that is the material of anode is M1, which is in contact with M1 raised to plus N, whose concentration is 1M. It is connected to salt bridge, which is in contact with M2 raised to plus 1 plus N into bracket 1M, or whose concentration is 1 molar, and which is in contact with metal 2. when voltmeter is connected. We know the condition is NTP and the concentration of solution in both the electrodes is 1 molar. Then this voltmeter shows the reading of EMF or E0 of the cell, which is calculated by the formula E0 of the cell is equal to E0 of the cathode minus E0 of the anode. So where do we get these E0 of cathode and E0 of anode? From electrochemical series. So as the reaction proceeds, there will be oxidation in anode, there will be reduction in cathode. So at the anode the concentration increases and there will be decrease in electrode material. In cathode the deposition of electrolyte material takes place, so there will be increase in material of the electrode. Then concentration of C1, it means it was before both are having the 1 molar concentration, but because of oxidation here the concentration of the anode increases, it is called as C1, but here the concentration decreases, it is C2. Now the cell is represented as M1, which is in contact with M1 raised to plus n, whose concentration is C1, which is connected to salt bridge, which is in contact with M2 raised to plus n, whose concentration is C2. It is in contact with M2. Now what is the voltmeter reading, which is indicated by the symbol E of the cell or cell potential. Electrode potential is individual electrodes, this is cell potential. So cell potential is calculated by the formula E of the cell is equal to E0 of the cell minus 2.303 RT divided by NF log of concentration of the anode or left hand side divided by concentration of the cathode, or E of the cell is equal to E0 of the cell. E0 of the cell we get it from the formula E0 of cathode minus E0 of the anode. So E of the cell is equal to E0 of the cell minus 2.303 RT divided by NF log of anode. Concentration of anode is C1, concentration of cathode is C2, that's why log of C1 divided by C2. So this is called as Nernst equation. So concentration cell is a galvanic cell in which both the electrodes are of same type, but the concentration of the electrolytes in which they are dipped in are different. So consider a cell which is made up of same material, but if the electrolyte is having the same concentration, that is 1m 1m, consider it is maintained at NTP, then voltmeter shows the reading of 0 volt, because E0 of the cell is equal to E0 of cathode minus E0 of the anode. Here either it can be a cathode or it can be a cathode, so both are same. But if we increase the concentration of one of the electrolytes, then concentration of that electrolyte is greater than the electrolytic solution of other electrode. So here C2 is greater than C1. The concentration of this electrode is more, because of this there will be reduction. So the place where reduction takes place is called as cathode. So because of reduction there will be electron consumption, which will create a drag through this wire. So the electrons starts to flow. So this in turn creates oxidation in the left hand side electrode. So the place where oxidation takes place is called as anode. So this cell is represented by M is in contact with M raised to plus N, whose concentration is C1, which are connected by salt bridge, which are connected to M raised to plus N, whose concentration is C2, which is in contact with M. So now it represents E of the cell. It is given by the formula cell potential, or E of cell is equal to 2.303 RT divided by NF log of concentration of cathode divided by anode. Here it is E of cell is equal to 2.303 RT divided by NF log of C2 divided by C1. This is called as Nernst equation for the calculation of cell potential in concentration cell.